talked about how to graph secant and cosecant graphs. And if you know how to draw sine and cosine graphs, they're going to be routine. For example, if you have a sine graph, for example, if you have this sine graph, how do you get the secant? For example, if this was sine of x minus pi over 4, how would you graph the cosecant of x minus pi over 4? How do you graph this? Well, the first thing is you graph this. And since it's not really what you want to graph, maybe we should dash it. It's going to help us tremendously in graphing the cosecant. Whatever secant they ask you to draw, you change secant to sine and you graph the sine. Now, wherever it crosses the center line, put a dot there. And then draw vertical asymptotes right at those zeros, right at those 3 dots. And then you kind of graph it upside down. And if you start here, so here's the real graph. And you draw the U upside down. But you don't touch the dashed line on the left. You get really, really close to it. Asymptotically close. You don't touch it. And you do the same over here. Never touch. And you find the lowest point down here, and you draw your upside down U, but you never touch it. And there it is. Look at the y-axis, and this the x-axis. This piece here, and this piece here, that's the secant. Excuse me, the cosecant. Let's draw one. You were asked to graph y is equal to 2 cosecant of x plus 3 pi. Suppose you were asked to graph this. Well, what you should graph is y is equal to 2 sine x plus 3 pi. Okay? You're asked to graph this, but you should say, I'm going to graph y equals 2 sine x plus 3 pi. Start is when the angle is equal to 0. When x is negative 3 pi, that's where we start. And we finish when the angle, x plus 3 pi, equals 2 pi. The x is negative pi. You take away 3 pi from both sides. The left side gives you x. 2 minus 3 is negative 1. Negative 1 pi. So we have the start and the finish, and it's the sine graph. I could have drawn it first. Make believe I did. There's your sine graph. Touch it there. The highest value is 2. The lowest value is negative 2. But a little bit, let me start that over. There is your sine graph. It starts at negative 3 pi. It finishes at negative pi. So in here is negative 2 pi. So this is a length of pi. I kind of run out of room to go pi, but make believe I go pi. So the highest value is 2. The lowest value is negative 2. And this is negative 2.5 pi's. And this is negative half pi. In between negative 2 and negative 3, in between negative 2 and negative 3, is negative 5 over 2. Negative 2.5. Negative 2.5 what? Negative 2.5, negative 5 halves pi. Okay, so there is your sine graph. Is it sine? Yes, it is. And since that isn't what we wanted, you need to remember not to draw it completely. Since it wasn't what we want, let's dash it. Whatever it crosses the middle, here, here, and here, you draw your vertical asymptotes. You draw vertical asymptotes. Vertical asymptotes. It goes like this and like that, and like this and like that. There's your graph. Now, I want to say something. I'm sorry I didn't mention this a long time ago, like in the last section. We've been drawing one period of these graphs. A sine graph. I said at some point a sine graph goes sine x, y equals sine x. I kind of said y equals sine x goes from 0. Let me draw it a little bit more narrow because I need more room. Okay, I said that was it. Sorry, that's not true at all. It keeps repeating this forever and ever and ever in both directions. Keeps doing this forever. I'm terribly sorry I didn't say that. But we're just drawing one period. One thing that keeps repeating. What I just highlighted, that keeps repeating. It's repeating here, and then here again. This keeps repeating. It keeps repeating in both directions. But we're just drawing one period. Okay, sorry about that. Just one period. So for the record, if we were to ask, so this is sine graph, if we were asked to draw a cosecant graph, every time it crosses the axes, we would have these vertical lines, and we would have an awful lot of them, because it goes on forever and ever. It goes on forever and ever. We even have one at the origin. It goes on forever and ever, and we would draw this. That is even the secant graph. It repeats forever and ever. It goes on forever and ever and ever. It just keeps repeating. It keeps repeating. Okay, even here. It keeps repeating. Okay, I should have mentioned that. I'm sorry. But okay, now that I mentioned it, we're just going to draw one period. And that's all your teacher's ever going to ask you to draw. So if the teacher asks you to draw the exact graph, it'll be there forever because it goes on forever. All right. So now, what if you were asked to graph y is equal to the secant, or 3 times the secant, or negative 3 times the secant of x plus pi? Okay. So what you graph instead first is y equals negative 3 cosine of x plus pi. Okay, so since it's negative, I draw it upside down. Here is my upside down cosine graph. And there's the x-axis. All right. And now I want to see where it stops. Well, it stops. And again, this is not the graph that I've been asked to draw. So let's dash it. And actually, I'm going to need more room for the top, I think. In case I need more room, pi plus pi is 2 pi. That is, x is pi. You need, and you really shouldn't, if you need, you take away pi from both sides. X is equal to pi. So we found out it starts at negative pi. It finishes at pi. 0's in the middle. And between 0 and pi is half for pi. And between 0 and negative pi is negative half pi. And once again, this was not the graph I meant to draw in the end. So let's dash it. And this graph will help us tremendously to graph the function or the graph that we really want to graph. And for the record, negative 3. So 3's up here and negative 3's down here. We find the zeros here and here. So I draw my vertical asymptotes. I draw my vertical asymptotes. And basically, each piece that I see, that is this piece here, I just draw it kind of upside down. It's not exactly upside down, because this graph is touching that dashed line. Touching right there. The cosine graph touched that vertical asymptote, but it doesn't touch there. The left piece, I start here, and I kind of draw it upside down, except I don't touch. The middle piece, instead of drawing this upside down U, I draw a right side up U. But I don't touch those vertical lines. There it is. Just graph it upside down. You have a piece here, a piece here, and a piece here. Those dots, those vertical asymptotes, is what separated this graph into 3 separate pieces. Okay. So drawing sines and drawing secants and cosecants is very similar to drawing sines and cosines. Just draw them upside down. Okay, let's draw 2 more complicated ones, the ones where we have a vertical shift, one where we add a constant at the end. Okay, we'll do one for secant and one for cosecant. Graph y is equal to 2 secant x minus pi plus 3. So we're going to first graph y equals 2. That's secant. We go cosine. X minus pi plus 3. Okay. Since it has the plus 3, let's talk about the high, the middle, and the low. Normally the high would be 2, the middle would be 0, and the low would be negative 2. Or somebody went and added 3 to everything. So we have to add 3. The high will be 5, the middle will be 3, the low would be 1. Now the middle is going to be important. Okay, where does it start? It starts when the angle x minus pi is 0. X should be pi. Pi minus pi is 0. It starts at pi. Where does it finish? It finishes when the angle is 2 pi. 3 pi minus pi is 2 pi. How many pi's do you have? How many peaks of pi's do you have? So if you take away 1 pi, that is, you eat 1 pi, now you have 2 pi. How many pi's did you start with? 3 pi. Okay, so we draw the cosine graph. Here is my cosine graph. It's a positive cosine graph. Of course, I'm going to dash it because nobody asked me to draw a cosine graph. There's my cosine graph. Wherever the y-x-axis is, let's temporarily call that the x-axis. We know it starts at pi, and it finishes at 3 pi. So in the middle will be 2 pi. This distance here is pi. So if I'm at pi and I go the same distance, I'll get to 0. That is, I may not yet know where their x-axis is, but here's the y-axis. Here is your y-axis. So let's get rid of this on the bottom because I don't know if it's right or not. Okay. Now, the middle is right here. This is important. Here's the middle, and the middle is 3. That is, 3 is right here. The lowest point is at 1, and the highest point is at 5. Okay, so I want to get rid of this on the side here because it seems to be in the way. 5, 3, and 1. And just get rid of this. Okay, 5, 3, and 1. Apparently this didn't come out. Okay, good. So there's the graph. And the middle is important. Oh, okay, so the y-axis should be, I meant to say the x-axis should be approximately right here. Okay. Now, I want to see where the cosine graph crosses the middle line. It crosses here and here. That's utmost important. So, I draw my vertical asymptotes here. And I draw my vertical asymptotes here. And here is the cosine graph. Okay, so I just draw it upside down. I come to the high point, I go like this. I come to the middle region, I go like this, and I go like that. The right here, I go like that. Here's my graph. And I should label the axes. It started at pi, and it finished at 3 pi. So the middle is 2 pi. In between 1 pi and 2 pi, between 1 and 2 is a half, so we have pi over 2. And between 2 and 3 is 2.5, or 5 halves, pi. So there it is exactly right. And, okay. Well, like I said, we'll do one more and we'll do our cosecant. Y is equal to negative 2 cosecant x plus pi plus 3. So first we graph y is equal to negative 2 sine, what I wrote, negative 2 sine of x plus pi plus 3. So the high, the middle, and the low. The high is usually the absolute value of that number. The middle is 0. And the low is negative the absolute value, negative 2. But we're adding 3. So the high is 5, the middle is 3, and the low is 1. 1, 3, and 5. Why does that sound familiar? Okay, now where does it start? It starts when that angle is 0. That is when x is negative pi. Negative pi plus pi is 0. It finishes when you have a number and you add pi and you get 2 pi. X should be pi. Pi plus pi equals 2 pi. The x is pi. Okay, so temporarily we'll say here's the x-axis. We know it starts at negative pi, and it finishes at positive pi. Okay, that's what I know. Here's my y-axis. I know that's my y-axis. And the lowest point is at 1. The highest point is at 5. And the middle point is at 3. And I'm to draw a sine graph, a negative sine graph that is upside down. So here's like the middle. Well, not like here, it is the middle. And I draw an upside down sine graph. Draw an upside down sine graph. And once again, I should have dashed it. Whenever it crosses the middle, namely here, here, and here, you have your vertical asymptotes. Now it's very hard for me to draw a dashed line on the y-axis because you put a dashed line on top of a solid line and it's solid. Okay? And if I go right on the line, you won't be able to see me, but it's there. So here's your graph. Go to this low point, upside down. Go to this point, draw it upside down. There it is. That's your negative 2 cosecant x plus pi plus 3 graph. Perfectly drawn. Except that should be called the x-axis. Okay, there it is. It's perfect. Okay, find the sine graph. Find where it crosses the center. And then draw it upside down. Okay, that finishes up secants and our cosecant graphs. We'll do tangent and cotangent graphs in the next video. Thanks.